Today I'm going to be designing a new small run injection mold. Welcome to another episode. This is going to be a longer episode than normal. I've had a couple people ask me to do a video of the whole process of creating an injection mold. So this is part one where I design the mold. This mold is a little bit more involved, not a lot, just a little bit more than some of the molds that I've designed in the past. So let me head to the bench and I'll show you the part that I'm going to be designing a mold for. This is a kit for a speaker enclosure. This is a small speaker. It's designed to go into a model train. And it's a press fit into this enclosure, which helps baffle the sound and prevent the sound from the back canceling out the sound from the front. I'm certainly not an expert on acoustic physics. This particular enclosure is printed by Shapeways. What happened recently is apparently they doubled the cost or the price of making these parts. So it's gotten a little bit prohibitive for TCS. And they asked me if I could make some short-run injection molds because the volume that they have doesn't warrant making a real injection mold. And what I mean by a real injection mold is one that has ejector pins. So basically, when the mold parts come apart, you've got some pins that automatically push the part out. The part drops, the mold halves come back together, and it can just keep making parts over and over again. What I'm going to design instead is a short-run injection mold, where I have to put the mold into the machine, take the mold out of the part, pull it apart, and then eject this part with a very simple ejector pin. The goal is to end up with a mold that consists of a core and a cavity. Let me hide the cavity. Here's the core. Generally the core is the part that has something that sticks up, and the cavity is something that has a hole in it. So if we look at the cavity now, you can see it has a hole in it. Now this mold looks fairly straightforward. There are a couple challenges that we'll run into when we create it. So let me go ahead and I'll switch over and start a new file and walk you through the process. I'm going to start by loading the STL file, the step file that I got. I like step files rather than STL files because you can modify them, as you'll see in just a minute. So this has a couple of things I want to change. First, I want to capture design history, and then I want to turn this into a component. So I'll say create components from bodies, and I'll call this the enclosure. Okay, so now I have that enclosure. I'll go ahead and modify the enclosure. First, I'll activate it. I need to add some draft. These walls are straight up and down right now, and that's not so much of a problem for the outside wall, but for the inside walls, the material will shrink and grab onto the mold. So I need to add some draft to these, which is an angle, so it comes out of the mold easier. I'll use a tool called draft for that. And I want to use this as the draft plane. Using this as the draft plane means that this outer circle right here is the critical diameter, so I'm not going to be changing that diameter. Now the faces I want to draft are these two. And let's see if I have the correct angle. So I have -3, it's going the wrong way. So I want to change it to +3, and now it's going the correct way. I now want to do the same thing for the inside. So I'll right click and say repeat draft. I'm going to use the same plane, but this time I'm going to use the outside face, and that's going the wrong way, so I'll invert it. And now if we take a look at a cross section, and I pick a plane here, you can see that the inside and outside walls are parallel to each other, which is exactly what I want. So I'm going to save this, and I'm going to save it to a folder called speakers. I already have the other file I showed you, so this is going to be a cleaner one, hopefully, than the one I had before. All right. Now I'm going to create the the two mold halves, what I'm going to do is just create material that's doesn't have the two different pieces. It's going to be one piece, and then we're going to split it apart. I want this to be the parting line. In other words, this is where the runner will come in and inject the plastic into the side of the part. So let me go ahead and start with a sketch. I'm going to create the sketch on there. I'll just create a rectangle, and then I'll constrain it in a minute. So the first thing I want to do is make this 2.5 inches tall, and that's because this is the size of material that the maximum height for the machine that I'm going to use. And the width, I'm also going to make it 2.5 inches. I'm not sure really matters exactly how wide it is. I want this to be centered vertically, so a trick I use is to create a line that's a construction line, and I'll go from the center point there to the midpoint of this line, and then I'll just make this vertical, and now it's constrained that way. The other thing is I want this close to being about halfway down. It doesn't have to be exact, but this is so that the clamping force is fairly evenly distributed around it. Okay, so that's the profile that I want. Now what I'm going to do is extrude this. I want it to be symmetric, and I want the half distance to be 0.5 inches, which is the, and I want it, oops, I forgot. I do this sometimes. I really wanted to make this sketch as a separate component. So what I'm going to do is I'm going to go back and create a new component, which is going to be the material. This is something that's temporary, and it's going to go away in a minute. And it's activated, and so now what I want to do is take this sketch here and drag it down to that. And so now you can see it changed colors to match this. Now that this is activated, I'll go back to the extrude, do my symmetric, make it 0.5 inches in each direction, and I want it to be a new body. So at this point, this material is hiding our actual part. I'm going to return the material back on and then select Enclosure so you can see what's going on. The next thing I want to do is subtract this enclosure from the material here. That will create a cavity inside. So I'll go ahead and say Modify, and then I'll use Combine. It wants the target body, which is this, and then it wants the tool body, which is the enclosure, right there. And I'm going to have it keep the tool bodies, and I'm not going to create a new component. I'll just keep it like this. So nothing really changes if we have the enclosure still on, but let me go back to here. I'll turn off the enclosure, and let's do another section analysis. So you can see it has removed that from the material, but at this point we still have a solid block of material. We don't have it in two parts. So we need some way to split this into two halves, which will become the mold halves. In order to split this into two halves, I'm going to go back to the enclosure and hide the material. And what I want to do is, oops, I want to show the enclosure. What I want to do is I want to create a surface that goes from here out, and that will be used as the cutting line to cut the two mold halves apart. It won't do it completely though, because there are these holes that go all the way through. So I'm also going to have to tell it where I want to cut it, on the top or the bottom. In this case, I want to cut it on the bottom because I'm going to have the pins come out of the part that projects out, because that'll be easier to mill. So I'm going to go into the surface workspace, and then actually what I'm going to do is roll this back. No, I'm going to keep it here. So I'm going to go into the surface, and I'm going to close these off. I'm going to just hit enter and then keep using the keyboard and the mouse, because that's a lot faster. I have those all closed off, as you can see, and now I'm going to create a surface that goes from here out by creating a sketch off here. And I'm going to create a projection. I usually like to rotate it like that so that I'm catching the edge that I want. And then once I catch that edge, I'm going to look at the top and create a rectangle that's larger than I need. I'm going to use a center rectangle. And I'm going to make these two sides equal. And then set the dimension to be 4 inches, which is way more than I need. Now that I have that, I can create a surface from that sketch. So at this point you can see that I have it completely closed off on the bottom there as well as out here. If I show the material again, you can see that that surface extends outside of it. The next thing I'm going to do is go back to here just so you can see what's going on with the different parts, and use another feature called boundary fill. I'm not sure why it's called boundary fill. What this will allow me to do is to split this part in two using the surfaces that I created. So the tools that I want are these surfaces here, and then I also need this body here. When I do that, you'll notice that I get these 3 checkboxes, and that allows me to select which part I want to keep. This will be the core, this will be the cavity, and I don't think this will produce anything. So I'm going to go ahead and create this as a new component. I'll select the top, and that will give me, oops, this happens sometimes. If you have everything selected and you forget to say select cells, it does something strange. So I'll just go back and do that really quickly again. Okay, now I'll click on select cells, and then I'll click that cell. And when I click OK and hide the material and the original enclosure, you can see I now have the core. I'll do the same thing to create the cavity. So I'll hide this guy, show the material and the enclosure again, as you can see. And then I can say fill body, boundary fill again. Select these as well as this body. And now for select cells, I'm going to use the bottom into a new component. And if I hide these guys, this is my cavity. So I'll go ahead and call this one the core, and I'll call this one the cavity. Then I'm going to hide the others. So at this point, I have the 2 mold halves. Next thing I want to do is I want to add the alignment pins. And the first thing I want to do is remind myself of which way is up on this. So if I go and click back on the sketch that I used to create the material, this is the line that I had going from the center to the top. So that tells me this is the top. I'm going to create the alignment pins down here. And so I'll go back to solid, and I'm going to create a sketch without selecting one of these components, because I'm actually going to cut the alignment pins into both the core and the cavity. So I'll create the sketch, and then click here to make sure, yes, that's still up. And I'm going to create a circle here that is going to be 0.24. It's going to be a 1/4 inch, so 0.25 inches, but I want to ream it to the final size, so I'll make it a few thousandths under. So I'll make it 0.247. And we're going to, 0.247 inches. And I'm going to use a reamer for that, as I said, and then interpolate this so that it's close in size. I'm also going to draw a sketch line here. And I like to make it a construction line. It doesn't need to be. But the purpose of that is to allow me to mirror this to the other side, so that when I decide where this is going to be, this is going to be the same place. So there are many ways that I can dimension this. One thing I'm going to do is I'm going to draw a line there, and then I'm just going to say, okay, let's have this be on the diagonal, and then I'll set the distance from this edge to be 0.5 inches. And you may wonder why I keep going between inches, and millimeters. And that's because I have things such as the speaker enclosure that is all in millimeters, and then I have things like the dowel pins I'm going to be using that are in inches, The blank size is in inches, etc. So I just kind of go back and forth. Okay, so now I have the location of the tool dowel pins, and what I'm going to do is I'm going to go ahead and say extrude. But before I actually extrude, I'm going to show the core as well, so that I can say symmetric, and then the total distance will be, these are 1/2 inch, so I'll make it 0.52 inches. It doesn't hurt being a little bit longer. And I want that to be the whole length rather than the half length. So now I have my two holes for the dowel pins. Creating the runner and the gate that goes into the part is kind of an art. You're going to see how I do it. Other people, I'm sure, do it in other ways. The idea, though, is that the sprue which comes in from the machine itself needs to be round for the best flow of plastic. I make it so it's slightly off from round, just so that there's a little bit of a draft on the sides, and you'll see what I mean in a minute. Again, I'm going to cut this through both the core and the cavity. Actually, I'm going to do it in a different way. What I'm going to do is I'm actually going to create a component that models the runner and the gate. I'll just call it runner. And then what I'm going to do is subtract that from both the top and the bottom. So I'll start by drawing a sketch along this face here, and I'm going to pick up this line here as a construction line. And then I'll turn that off, go back to the front. And then I'm going to draw half of a circle. Well, kind of a circle, as you'll see. So I'm going to use a 3-point arc. Okay, so this has no constraints right now, but I'm going to start by constraining this so it's vertical to here, which will make it centered. Then I'm going to constrain this distance here, which is what's going to give me the draft. So I'm going to use 0.005 inches. And then the diameter that I'm going to use for this is going to be 1/4 inch, 0.125 inches divided by 2. Okay, so that it's a little hard to see, but that has a little bit of an angle on the end because it hasn't quite finished the circle. Then I want to mirror this so that it becomes both sides. And extrude that, which will be the first part of the runner. And I'm going to go 0.4 inches. That wasn't 0.4 inches. Let's try that again. 0.4 rather than 4. I don't know if this is the right length. We'll figure that out. I'm going to add another sketch here. And for this one, I'm going to just do a projection of this and this, which will give me the half circle so that I can basically revolve it and turn it into the part that goes into the gate. So we'll revolve this around this axis here. Join. Okay, and that's not going far enough yet, but that's okay. The next thing I want to add is the gate. So there are several different ways to do it. I think what I'm going to do is a projection from above and then extrude it with draft. So I'll create a sketch here, and I'm going to hide the cavity at the moment. I'll create a rectangle, and I'm going to project this line here. And there are a couple of reasons for doing that. One is I want to do the alignment trick that I showed before. And then I also want to set the distance here. 1 millimeter is fine. Actually, 0.1 millimeter is good. Basically, I want to make sure that this is inside there. Width of the wall width on the... I'm going to stop this. I need to check the wall width on the enclosure. I believe this is... let's see, that's 14 millimeters and that's 15. Okay, so it's 1 millimeter is the wall thickness. And the reason that's relevant is because I want the gate to be about the depth of the wall thickness, something like that, and then I want it to be a little bit wider. So I'll go ahead and edit this. And so I'll make this 1.2 millimeters, and then this distance, then there's another distance I want to select as well. And for that I need to have a projection of this. Let's see if that works. No, I was hoping to get a projection of this curve here because I want, this distance here, but it's not letting me do that. So I'm just going to have to set some dimensions here. So I want this to here to be about 2 millimeter. Let's try that. That looks about right. I'll make it a little bit longer. That looks too long. 2.5. What I want is it to intersect the plastic about here, but because of draft and other things I need to make this a little bit longer. Okay, now I'm going to extrude this. I want to extrude at -1 millimeter. Millimeter, not meter. I want it to join, and then I'm going to give it about a 5-degree taper, -5 degrees. And that taper basically helps it come out of the mold a little bit easier. Okay, so if I turn my cavity back on, you can see that doesn't go far enough in. So I'm just going to change the extrude on this. There's probably a way to do this through parametrics, but I'm just going to do trial and error, which, as I say, is not the best way. But for molds, I'm probably not going to be changing this once I have it working, so this approach is fine. And at some point I'll probably do a different approach where I work my way from here back. And that's probably a better way. So do 0.5, not quite enough. See, I want it to completely go into the cavity there. So I'll go too far, 0.54. That is actually really close. So I'll just back it off a tiny bit. And partly what's going on here is I'm used to what I want this to look like. So I don't want this to be really long from there to there. And so I'll go ahead and make it just a little bit shorter. And that looks pretty good. Okay, so now I need to subtract this from the core and the cavity. And this is where we use the modify again. So I'll go to the cavity and I'll select, and that's just so that it becomes part of that feature or component. So I'll select combine. This is the target body. The tool body is this guy. And I want to keep the tools. So I'll just go ahead and cut that. And now you can see I have the cut in the cavity. Now I want to do the same thing with the core. So I'll say activate the core, do combine, target body, tool body, okay. And now I'll hide the runner, and you can see that I now have it in the core as well as the cavity. In the next episode I'll be working on the cam, and then I'll be making the injection mold, and then finally hopefully making some parts. My goal is to have them done by less than a week from now, because in a week I'm flying to TCS headquarters to spend a week there working with the guys on the throttles. And I'm hoping to bring some samples of these parts to them. I hope you enjoyed this episode. If you did, please give me a thumbs up. If you didn't like it, give me a thumbs down. But more importantly, please put a comment down below saying why you didn't like it or what you would like to see different. Also, if you'd like to be notified of episodes when they do come out, please click on the bell next to the subscribe button, and I'll see you next time.